we have two fabulous presenters. And the topic this evening is global climate variations, a looming crisis or natural changes. And as we've been talking, it was pointed out that science is quite a field because you have to, first of all, collect data. Then you've got to analyze and interpret the data. And often, what seems like the same data may come out as a different interpretation. And this is our challenge. As we grow wiser as civilization, I think our whole approach is going to become wiser. And this evening, we have two fabulous presenters. I'm going to introduce them now. And then they're each going to take 30 minutes to present one side and then the other of this question. We're going to have questions and answers. But so that everyone can hear, we're going to ask you to write your questions down. So Heather, if you'll pass out the index cards, and we have some pencils to everyone, you can write the question down anytime you want. We'll collect them after the presentations. And then that way I can ask the question and we'll have Kent and Steve respond. Now this evening, it really was quite fun as we were visiting beforehand because they both said, you know, we're excited about this because often it's only one of us that's speaking and we like to have some of the other side and questions and ideas and so on. So that's, this is really something unusual, they said. And I like to point out that Dick Jankow in the back has really been the stimulus for this. He is a retired electrical engineer, very interested in climate change. And he said, let's see what we can do here in Wilmette to bring this knowledge and present it to us. Now, thanks, Dick. Now, the presentation tonight, while in the style of a debate, it isn't meant to create a lot of rabble-rousing, okay? Because we're a very polite North Shore audience. And so I think we're going to have a great time. We're going to enjoy it. And after the questions and answers, we're leaving about a half an hour, 20 minutes, half an hour, that you could come up and talk to each, both to Kent, to Steve. Steve has some books. He's going to sign some books if you'd like. And in that way, you can really follow up even more with them. But during the presentations, let's listen attentively. Now, let me introduce each, and that way I won't break from the flow. First tonight, Kent Taylor will be speaking. Kent's a longtime resident of Chicago, in the area. And at Michigan State, he took, and I'm from University of Michigan, so it's okay. We come to terms with that. But at Michigan State, it started following up on his environmental interest. And what I found very fascinating is that when I took my daughters down to the Shedd Aquarium when they were young, and we saw that fabulous round coral reef tank in the middle, it may well have been Kent who was in the dive suit doing the presentations. That's some of the volunteer work that he's done over the years. And he also interfaces with the Coral Reef Research Institute in the Caribbean, studying the effects of global warming there. And then when he learned that Al Gore was seeking volunteers, he spoke right up, and in 2006, he then began to participate, and the 3-day training was quite impressive as he was describing it. He now helps in training others, and he has done 100 or more presentations in the area. So, Steve Gorham, I've got to tell you, is a remarkable speaker in his own right. He is now an author and a researcher. He was an electrical engineer, he was saying, an executive in the corporate world when this caught his interest. And he's traveling around the country speaking to groups and conferences now. He's also frequently invited as a guest on radio and television shows, and he is a columnist for the Washington Times. He is the executive director of the Climate Science Coalition of America, which is a non-political association of scientists, engineers, and citizens dedicated to informing Americans about the realities of climate science and energy economics. So he's authored 2 books, and the most recent, you'll love the cover, it's called The Mad, Mad, Mad World of Climatism, Mankind and Climate Change Mania. So and there's over 100,000 copies in print now, but he has some here, and you can follow up after the questions and answers with Steve.
Thank you, Bob.
So Steve, thank you. And let's give both of them a big round of applause right now. We are delighted that they are here, and we're going to ask Kent to begin.
Thank you, Bob, for that great introduction. And thank Dick, RC. Thank you very much for putting this together at your own expense. You are a true American citizen. I appreciate it a lot. I thank the audience for being here tonight. We're going to get into the weeds a little bit on science, so bear with us. But I know this is a well-educated crowd and well up to the task. I'd also like to thank Al Gore for the inspiration and the training and the support that he and his organization, the Climate Reality Project, has given to me over the last 5 years. The debate tonight is about anthropogenic global warming, in essence. Is it happening? Is it not? And if so, is it the major cause of the warming that we both, Steve and I, agree is taking place? The position I'm going to take is the affirmative, and I think the reality position, but we'll debate that later. What you'll see from me tonight, every word I say will represent the current scientific consensus. I know my worthy opponent tonight cannot say that and actually relishes in the fact that he's taking on the whole scientific establishment. Everything I say will be supported by 97% of climatologists studying in the field. But who am I, and why am I up here making this presentation? Why do I go to hundreds of venues and talk to people about the tough truth, the inconvenient truth of climate change? I'm not here to sell anything. I'm here merely to represent what I consider the current scientific knowledge in the field and see if we can convince you that we are a major component of this problem. My journey, how I got here, started out in St. John. It's an island that my wife and I go to for 20 years. We've been diving on the reefs of St. John repeatedly, and we love it. It's mostly a national park. There's a picture of me, a rare picture of me, shortly before I was attacked by that enormous sea monster. But usually I'm doing the photography, and these are the images of some of my friends that I've fed in the coral reef tank and have photographed and observed for years. And they're all dependent on healthy coral. And what my wife and I started to realize very soon was that as we visited our favorite reefs, they changed. They bleached, become whiter, and they had died. And forcing us to dive deeper and find reefs that weren't. We were watching geologic change take place in a human timescale. And this is what's so unusual about the climate crisis. And I realized that all my favorite animals that reside on the reef, which is the most endangered ecosystem in the entire planet from climate change, would become extinct if we lost the reefs. And then this happened. In one fall, 4 months, the hottest year on record till that point, St. John lost 50% of its reefs. 50%. And this shocked me, and it scared me. So I'm up here because I'm scared. I think you would be too if you went to visit your national monuments that you enjoy, and the next year came back and found 50% of them gone. So this is shocking. and this is why I had to get involved. I resigned from the Shedd Aquarium as volunteer emeritus with over 3,000 hours of service to that incredible organization because I needed a wider audience. Because this is a global problem. Over the last few decades, the amount of tropospheric or CO2 has increased rapidly in the area of the atmosphere that we live in, the troposphere. Since the Civil War and the invention of the thermometer, we've been able to track temperature, but we also, through proxies, able to track CO2. And you can see that it's been rising steadily since the 1860s, especially lately, in the last few decades. In the beginning of the instrument record on CO2, this is the result of the measurements that have been going on. It's as solid and as ominous a curve that there is in science. What's been going on as this CO2 has been accumulating is the Earth has been heating. It's been heating in the troposphere because we're supercharging the greenhouse effect. As you see the dates pass here, you can see that a lot is cold and hot, and it seemed very random, but then as we get closer to today's date, we're seeing much, much more of it start to collect and not go away, especially in the northern hemisphere and the Arctic Circle. Well, Steve and I agree the planet is warming. We have our differences as to why. So far, it's warmed at least a degree since the last century. Now, the people who deny what I'm going to talk about today say all the pollution and carbon that we're putting up in the atmosphere couldn't have anything to do with it. It's something else. They know it just has to be something else. And we're going to find out what it's going to be from Steve. But I think tonight you're going to hear a few red herrings. We all know what that is. To divert attention from the problem. So I'm going to try to preempt Steve a little bit and talk about some of the ones from reading his excellent books.
It's called sunspots. Yes, solar activity. That explains why one sees similar temperature cycles on Mars and Jupiter to the cycles that are happening on this planet. That's why ice caps on those planets, like on ours, expand and contract. It's the sun, stupid.
That from the halls of Congress. Yes, the sun is probably the major climatic forcing mechanism, has been throughout history. Sun irradiance is what he's talking about because the sun's intensity temporarily increases and decreases, sometimes for many, many years. Over the course of history, the sun has been a huge influence in temperature variation, and I believe my opponent tonight will be talking about some of these eras in history. Keep in mind that the sun's irradiance varied greatly during these periods. And all along has been a terrific proxy for our temperatures. Along about 1980, this correlation broke off. So what we have here is another red herring. Solar activity since 1980 has been steady to actually a little bit less. Our temperatures continue to go up. There is no longer the strong correlation there used to be to sun radiant energy and the temperatures on our planet. This also coincides with our sun being 1,000 kilometers further away from planet Earth than it was 2,000 years ago. So, in my opinion, and the opinion of experts, solar forcing is negligible from solar forcing is a negligible force in climate change. This myth has come up so often, this led to one famous researcher to offer this tidbit as to what he thought of it. It's quite a canard, and it frequently comes up. And the reason it keeps coming up is because oil and coal companies who are dumping this pollution into the atmosphere might not be able to dump it all. They may have to leave a lot of that in the ground. They've already purchased it or leased it. So they're contributing a lot of money to organizations, individuals, and groups to get this word out that it's not so bad. A little climate change isn't bad for us. But is there anything else besides the sun they can blame it on?
When you look at a volcanic eruption, which I've seen scientists reveal that this could be 50,000 times what man's involvement in terms of creating CO2 would be, you begin to scratch your head and wonder, wait a minute, what is this?
Thank you, Speaker Boehner. But the reality is, volcanoes emit a pittance of CO2 compared to human civilization. Human civilization emits 200 times the amount of CO2 in a typical year than volcanoes do. So that can't be the source of this extra CO2. Skeptics claim that, oh, we're just relying on computer models. That's not accurate. But there are multiple human fingerprints, 12 separate and distinct lines of scientific evidence that show that humans are the main cause of this warming in the last 200 years. I only have time to talk about a few of these tonight, so bear with us while we do. But confronted with this overwhelming evidence, the denier community is frequently reduced to ridicule. They particularly love to say, CO2 isn't harmful. We breathe it out. And I like to add, yes, as a waste product. But let's hear what some of the leading intellectuals of this movement have to say.
This show has won so many science awards. Sometimes we get talking about highfalutin science, things like this, and people are like, what are you talking about? So let me just break it down. Carbon dioxide is basically this. Look how much pollution I just put out.
Well,
George, the idea that carbon dioxide is a carcinogen that is harmful to our environment is almost comical.
it's not almost comical, it is comical. Other, more red herrings. Reality is, no one has called CO2 a carcinogen. CO2 traps heat, lots of heat. And that's all we say. It's simple physics. But in the desperation to discredit people like myself, they attack the messengers. Or the climatists, which actually I'm happy to say I am. Here's one of their latest billboards. That's me they're talking about. They're comparing Al Gore and people like myself to Ted Kaczynski. Now, this cost the Heartland organization considerable. They lost all these corporate sponsors because of this simple bulletin board, or billboard. But notice no coal or gas companies or oil companies withdrew their support. I guess they feel this is just fine. To deny what's going on today is to deny the physics of the greenhouse effect and the carbon cycle. It's pretty much that simple. The carbon cycle, we need to explain, just to refresh people from the 10th grade math and science classes. There are 3 stores of carbon in our atmosphere. In plants, in our atmosphere, pardon me, in the world. In plants, in the atmosphere, and in the oceans, exchange the carbon that they store in a fairly balanced manner. The 4th store is underground, plants that are buried and rot and are covered up, eventually millions of years later become oil. And the geologic plan was that carbon was never see the light of day. And the carbon exchanges that do exchange, everything will be in balance. And that's how it's been for thousands and thousands of years. Then we discovered oil, and everything changed. Policies of this nation and many others became one of extracting as much carbon as possible from the ground and putting it into the atmosphere as fast as possible. And we now know this is an unsustainable path. We're now digging out of the ground captured sunlight. Sunlight energy that for 17 million years worth so far since the Industrial Revolution, and putting the carbon in the atmosphere with no natural sink for it to fall into. and we're resulting in a large imbalance. This is our doing. That's us. And that imbalance affects the greenhouse effect. John Tyndall came up with the greenhouse effect in the middle of the 1800s. He identified certain vapors, or gases as we know them now, that trap heat and as a result keep our planet from being a cold rock in space. And he was right. Average temperature on the Earth would be 63 degrees cooler, or -4 degrees on average, if it wasn't for the greenhouse effect. Just 400 parts per million of CO2 in our atmosphere gave us 63 degrees of heat. Not much was done with this on this subject until savant Arrhenius, the father of physical chemistry, one of the first Nobel laureates, theorized that the CO2 that the Industrial Revolution was releasing in the atmosphere could have an effect in raising our climate temperatures. And he was very concerned because, as he knew, there is a natural amount of greenhouse effect that is very good for us. But as we add more CO2 and other greenhouse gases to the atmosphere, it traps an unhealthy extra amount of warmth, which is anthropogenic global warming. That's what I'm talking about here tonight. Now, on a planetary scale, this plays out in this way. The Earth and Venus are fairly similar in size. They have roughly the same amount of carbon. The Earth has a wonderful carbon cycle going, and Venus has no life and no carbon cycle. So most of the carbon that was in its atmosphere remains in its atmosphere. The result of this is Earth has a marvelous 60-degree average temperature, roughly, and Venus 855 degrees. Now, some of you will say, well, that's closer to the sun, Kent. That makes sense. And then explain Mercury. Less than half the temperature of Venus with literally no atmosphere, no greenhouse effect. It is possible for a greenhouse effect to literally generate hundreds of degrees of temperature just from that. And all we're talking about here in the debate today is 5 or 6 degrees. Now, we couldn't test Arrhenius' theory until Charles Keeling invented a machine that could measure in real time carbon, CO2 in the atmosphere. He teamed up with Roger Revelle, and the two of them came up and started measuring CO2 in our atmosphere in the 50s. And every year they turned and spread research stations all throughout the Pacific. And this is the Keeling curve, one of the most dramatic and famous images in science. This is our CO2 record. And if CO2 goes up, physics tells us, John Tyndall tells us, Arrhenius tells us, the temperature has to follow. Scientists say that if we keep on the present course of growth and use of fossil fuels, we could see our greenhouse effect magnify 3 to 10 degrees, just in the next 100 years. But many skeptics say the temperature rise has stopped. No, it stopped many, many years ago now, maybe 16, 17 years ago. But all 4 global organizations that measure temperature disagree. Although all their records differ, depends on where their sites are, they all show the same trends. And if that isn't enough to prove that we've raised temperatures on this planet, I now offer this incontrovertible proof provided by the fashion industry. It seems that they figured this out before much of anybody did. So if temperatures leveled out, really? Only if you cherry pick the data. You've seen this chart a lot, I'm sure. This is the average temperature of the 20th century, and since the invention of the thermometer, global temperatures. And you can see how we've stacked high temperatures here in recent years. Let's take a look at this year 1998. It's an anomaly. Very high El Nino effect. Solar cycle was right. It was an anomalous year, hottest temperatures in history. And this is the hobby horse that the deniers ride. Because every time they want to say it's leveling out, they always have to start with 1998. All right? Because then they'll say, well, it's been A few years ago, they're saying, well, for the last 15 years. And the last year, they're saying, well, it's the last 16 years. They always include 1998. Because if they didn't, that would not make sense what they're saying. When a skeptic looks at climate, they can cherry pick and make any assumptions they want by connecting the dots in any number of years that they want. Realists look at the entire population of data and the long-term trend lines. That's where we differ. As CO2 goes up, temperature goes up. It's just physics. Where is this temperature going? Why aren't we as hot as some scientists predicted we would be by now? Our ocean has been a benefactor. It is absorbing a surprising amount of heat. But that's not good for the oceans. It's been great for us. They've acted as a shock absorber, giving us a little breathing spell. But unfortunately, it's changing its ecosystem dramatically. And I can attest to that. So this cannot go on forever. And as ocean heat content goes up, ocean levels rise. Being a liquid, as it warms up, it expands. That's all it takes. And you can see it's been going up for 100 years, but it's doubled its rate of increase since 1993. So what about before the instrument record, before the invention of the thermometer? Well, to investigate that, we have to use ice core samples. These are from Antarctica, and the ice cores go back 400,000 years. I have data from 850,000 years. It's basically the same. You can see that CO2 has remained in a strong band between 180 and 280 parts per million, and you can see here how the temperature follows it, almost like a lock and key. You want to see where we are today? Higher than we've been in nearly 1 million years in terms of CO2 in our atmosphere. And if we fail to act by the end of this century, we're going to be off the chart in uncharted territory. No questions. No questions until the end. Write it down, sir. Thank you very much. Our living atmosphere is only 6 miles deep. It is theoretically possible to fill the entire troposphere with greenhouse gases. And we're doing a pretty darn good job of it at the rate of 90 million tons a day. This is our contribution to our environment. So let's go back to these grids again, or these lines again. Here we are today at 400 parts per million. Let's add the temp. This is the average CO2 levels for the last 1 million years. So you can see how much higher we are above the average. As we've said, temperature always follows or precedes. Sometimes in this example, the temperature went up before the CO2 went up. In geologic time, it's also been reversed. It doesn't matter because they always go together. You can't have one without the other. It's like bread and crust. Let's add another one, sea level, another fluid. Our atmosphere is a fluid. And it too responds to these changes in temperature. An eerie correlation. So if we do not change our habits with energy, we're going to see the CO2 go up, followed by both ocean levels and temperatures. This is physics. But aren't there natural forcing mechanisms out there that affects this? That's what we're looking at, just natural things that happen? Yeah. Volcanoes affect temperature in our climate. Yes, they do. They actually cause the temperature to drop a little bit because they put particulate matter in the atmosphere that shades our planet. El Niños and La Niñas affect our climate. El Niños heat it up a little bit, La Niñas the opposite. You can see from this NASA diagram that these natural forcing mechanisms do have an effect. Volcanoes go off, temperatures drop. El Niños erupt, temperatures go up, and the opposite for La Niñas. But look at what's happening. It doesn't matter. The trend is upward. The highs are higher and the lows are higher because we're overwhelming these natural forcing mechanisms. The CO2 mixing ratios are now the largest sustained radiative forcing in our atmosphere. So where does this extra CO2 come from? Who's providing it? Maybe it comes from the oceans. Maybe they're belching it up, undersea volcanoes. Well, if it was from the oceans, we would see studies that would show a decrease in carbon in our oceans. Is there any evidence of this? None. There's been no study that shows a decreasing amount of carbon in our oceans. Conversely, there are over 20 that say the opposite. No, the carbon is not belching up from our oceans. So, is the Earth's greenhouse effect going into overdrive? Yes, in my opinion. But is it our fault? This is not a coincidence. There are distinct human fingerprints on this excess CO2, and we're going to go through a few of them today. This is the big one, of course. Our just coincidental exponential increase in CO2 emissions by our society. Atmospheric CO2 has gone up 40% since the Industrial Revolution. Mostly from greenhouse gases and some from the way we use land. The greenhouse gases come from all aspects of our civilized life. So many things that we do generate greenhouse gases we don't even realize it anymore. Another human fingerprint. The daytime temperatures are certainly breaking records, but nighttime even more. Last year, we had records broken and tied all over the country. But at nighttime, when the sun isn't shining and only the greenhouse effect is warming it, the Earth, even more records, twice as many records were broken. That is a fingerprint of greenhouse emission, or our greenhouse effect being supercharged. Now, one of the most compelling arguments involves carbon isotopes in the atmosphere, because scientists can actually find the origin of carbon molecules they can be identified from from their origin. This is a very complex but extremely compelling argument. I want you to stay with me here because I think it's the smoking gun. This is what you can't get around. Natural forming carbon is in 3 isotopes. 12, which is 99% of our atmosphere, carbon-13, about 1%, and the unstable carbon-14, which is just a trace element. Now, plants prefer to absorb carbon-12. It's easier for their photosynthesis. So their ratio of carbon-12 is higher than the atmosphere in general. And these are the plants that millions of years ago were growing and now are our oil. So when oil is burned, it releases a carbon ratio similar to plants. We also know in reference the fingerprint of the plants that are now living and rotting on the ground and our oceans, so we can identify and distinct carbon isotopes. And the ratio now is changing, much as a freshwater stream going into a saltwater lake. Very gradually we're increasing the ratio of carbon-13, carbon-12 to be more like plants as opposed to what the atmosphere has been. So are we seeing this? Yes, we are. As our CO2 emissions have gone up, you can see that the ratio is falling. Notice the inverted scale here for clarity. The ratio is falling in correlation. That's our fingerprint. There's another one. As we burn fossil fuels, what do? We consume oxygen. So are we replacing CO2 with oxygen, or replacing oxygen with CO2 in our atmosphere? Yes, we are. Dr. Keeling discovered this as well in the same measurements. Our oxygen levels in the atmosphere are steadily going down. Not a threat to us or animal life, but a very interesting phenomenon for scientists to measure. So it's another human fingerprint. Now, the one I'm going to talk about is the stratosphere. The troposphere is where most of our weather occurs and where the global warming occurs. This is the stratosphere. Now, normally, you'd expect if it was the sun increased radiance causing this heating, the troposphere and stratosphere would be heating equally. But that's not the case. What was going on as we add more greenhouse gases to our atmosphere and intercept some of this radiant energy, it doesn't get to the stratosphere. So the stratosphere is cooling. And that is totally as predicted by climate scientists who agree with my approach. So have we supercharged the greenhouse effect? In my opinion, yes, we have. In the opinion of the consensus opinion of scientists, spectral evidence from satellites has confirmed that we have energized our greenhouse effect. Now, if you are going to agree with my opponent tonight, there are two things that must be true. One, something unknown is suppressing the well-understood greenhouse effect, even though all these greenhouse gases are going into it. That isn't the problem. The greenhouse effect is somehow not the problem. The second unknown is that we're causing that something is causing this that we just do not know. We don't know where it's coming from, but it mirrors the effect of greenhouse emissions. So we can either accept what we know to be true, or we can accept two unknowns. And this is a too important topic for us to accept unknowns. And I yield the stage.
Thank you, Kent.
Well, good evening. Great to join you tonight. Nice to return to Wilmette. Both my parents, Henrietta and Art Gore, taught physical education in Wilmette for 30 and 40 years. I played basketball here as a youth. I played 16-inch softball when I was older. It's nice to come back and visit.
Nice. That was the third one.
So I want to start with a discussion of temperature first. And a quote by the IPCC: "The increase in temperature in the 20th century is likely to be the largest of any century during the last 1,000 years." I want to show you exactly what they're talking about. This is a look at temperatures for Chicago over the last 140 years. And for each date of the year, from January 1st to December 31st, it shows the record low temperatures, that's this green curve, for each date, the record high temperature for each date, and the average max and min here in the middle. Our records go from about minus 25 Fahrenheit up to about 103 degrees Fahrenheit. And in a typical year, we go about 100 degrees temperature-wise. Now, I'm going to superimpose on this the extent of global surface temperature change in the last 130 years. Oop. There it is. It's captured within that line. Now, that is the temperature rise that the IPCC says is unnatural in history, and has to be due to man-made greenhouse gas emissions. And we've often heard that the glaciers in Glacier National Park are melting, the snows of Kilimanjaro, the Arctic ice is melting. Melting is, and Mr. Taylor mentioned temperature records. All those things are evidence of warming, but not what is causing the warming. Another thing you may have heard of is climate change is real. Well, that's a true statement, but it's a meaningless statement. Global warming is real. Global cooling is real. Climate change is not only real, it's continuous. It's been happening for all of Earth's history. And two well-known periods of climate change are the medieval warm period and the Little Ice Age. The medieval warm period was a period from about 900 to 1300 AD, when the Vikings settled southwest Greenland, and they founded a colony at Helvasi 600 years before the Jamestown colony. That colony farmed, it raised livestock, it traded polar bear skins, and it grew to a number of 5,000. And at that time, the historical records, the Book of Icelanders, said that there were trees 6 meters high in southwest Greenland. Well, this is that church today, and as you can see, all we have is scrub grasses. Hundreds of peer-reviewed studies show that it was warmer 1,000 years ago than it is today. About 1300, the temperature cooled, and that that colony died out, and we entered the period of the Little Ice Age. The Little Ice Age is a period of cooler temperatures, not a true ice age, but 1 to 2 degrees Celsius cooler than today. Very tough time in Europe. We had shorter growing seasons, famine in Europe. The population of Iceland declined by about 50%. But in London, they had a festival every year on the frozen Thames River called the Frost Fair. And they'd bring out their horses and wagons and build sheds right on the river. Well, you can't do that today. The Thames River has not frozen solid for more than 100 years. These are two natural periods of climatic change. Nothing to do with carbon dioxide, nothing to do with carbon dioxide emissions, just natural climatic changes of Earth. Another period was the Roman climate optimism. About 2,000 years ago, it was very warm in the Mediterranean. And we had those Roman soldiers running around in those short skirts. Well, at that time, our olives were harvested in central Germany. You can't do that today. Wine was grown commercially in England. Another period of natural warmth, nothing to do with man-made emissions. And if we look at more quantitative data, this is a graph of temperature from proxies. We start here at the present day, go back 2, 4, 6, 8, 10,000 years to the end of the last ice age. By the way, where would we be if we were in this very spot 20,000 years ago? Under 5,000 feet of ice. We see the temperature warm and it cools and it warms and it cools. Here's the medieval warm period, here's the Little Ice Age, and here's the modern warm period. Now, one of the things you may have heard in the press is that the decade from 2000 to 2009 is the warmest on record. Very alarming statement, but it's a misleading statement. The record refers to the thermometer record, which is only 130 years long. I'm going to show that to you on the graph. That little green dot there, that's on record. That's the warmest on record this decade. And Mr. Taylor put up a lot of charts from 1970 to 2000 and 1950 to 2000. Those are very short time periods in terms of temperature when you talk about the climate. And the idea that this is the hottest on record and is something abnormal ignores all the evidence we have of the warmer and cooler periods in the past when temperatures were warmer than they are today. And this little rise here, coming out of the Little Ice Age going into the modern warm period, I'm going to refer to that again, so remember that. Here's a picture of a white spruce stump located in the Northwest Territory of Canada, north of the Arctic Circle, up by Alaska. It's a very old stump. It's been radiocarbon dated to be about 5,000 years old. But the interesting thing about this is that it's located 100 kilometers north of the tree line today, 100 kilometers north of any other white spruce tree, indicating that it was warmer 5,000 years ago than it is today.
Where was this?
Now, New Jersey Governor Chris Christie has said climate change is occurring and humans play a contributing role. Many people have said that. I agree climate change is occurring. Climate is always changing. And I agree we contribute. But if you have a dog or a cat, that contributes to climate change as well. The important thing is how big is the human contribution to climate change? Earth's climate is complex. It's shaped by powerful forces from our solar system, our atmosphere, our oceans, and the land. For example, sun falls directly on the equator and much heat energy is absorbed. It falls indirectly on the polar regions and little energy is absorbed. All weather on Earth is driven by this temperature difference. Jet streams, hurricanes, storm fronts, ocean currents are all a redistribution of heat from the tropics to the poles. The oceans have 250 times the mass of the atmosphere. And the oceans can hold more than 1,000 times the heat of the atmosphere. And then we have aerosols that are given off by volcanoes, desert dust, pollen from plants in the ocean, man-made emissions. All of these things go into shaping the climate. Yet climate scientists are obsessed with carbon dioxide, a tiny part of the whole picture and a tiny part of our atmosphere. Matter of fact, carbon dioxide is a trace gas, and it's been going up, but the question is that really significant? If we compare 10,000 molecules in our atmosphere to 10,000 kilometers on a flight from O'Hare to Narita Airport, about the time we took off from O'Hare and we went 4 kilometers, we were over Bensonville, we will have exhausted all of the carbon dioxide in the atmosphere. Only 4 of every 10,000 molecules in our atmosphere are carbon dioxide. The amount that mankind could have added in all of human history is only 1 of those 10,000 molecules. In our flight, we wouldn't even be off the runway before that was exhausted. Now, Mr. Taylor talked a lot about carbon dioxide as a greenhouse gas, but he forgot to mention and emphasize what nature's most abundant greenhouse gas is. It's not carbon dioxide. It's not methane. The answer is water vapor. Somewhere between 75 and 90% of Earth's greenhouse effect is caused by water vapor and clouds. If we're conservative and we say 75% is due to water vapor and clouds, then the last quarter of Earth's greenhouse effect is primarily due to carbon dioxide with a little bit of methane. But then we need to ask, well, how much of this last quarter is due to man-made emissions? Again, Mr. Taylor talked about 90 million tons a year that goes into the atmosphere, but the oceans and the land exchange 25 times that much every year. They emit and they absorb that much carbon dioxide. As a matter of fact, the oceans contain 50 times as much carbon dioxide as the atmosphere dissolved. And when plants grow, they absorb carbon dioxide. When they die, carbon dioxide is released. And then we have volcanoes, both above the surface of the ocean, and about 10 times as many putting gases into the environment under the ocean. So when we look at this last quarter of the greenhouse effect and we break this down, it turns that 96% of that last quarter is due to natural emissions of carbon dioxide from the biosphere, the oceans, and a little bit from volcanoes. That means the man-made portion of the greenhouse effect is 1 part in 100. 1% of the total is what mankind is producing. If we completely eliminate all emissions, we probably could not measure the difference in global temperatures. Now, scientists will tell you that carbon dioxide by itself cannot cause dangerous warming. And the reason is that the absorption of infrared radiation by carbon dioxide in the atmosphere is nonlinear. The first carbon dioxide in the atmosphere contributes the most to temperature, and then as we add more and more carbon dioxide, we get less and less of an effect. We're about here right now. Even if we double atmospheric carbon dioxide from natural emissions or from man-made emissions, we would only raise global temperatures about 1 degree Celsius. So how do the climate models get their alarming projections? Well, the answer is they all assume what's called a feedback from water vapor. And it goes like this. They say temperature's going up. We have carbon dioxide helping to raise that. Well, we're going to assume that the atmosphere is going to hold more water vapor. And since water vapor is a big greenhouse gas, that will add additional warming. So with this positive feedback, we can now project 3, 4, 5, or 6 degrees of increase. Most of the increase projected is due to water vapor increase. But the data does not show that atmospheric water vapor is increasing. Matter of fact, studies have shown that clouds may be reducing warming from carbon dioxide. Matter of fact, when you think about it a little, this is all a little improbable. This is all a little improbable. Think of how powerful the water cycle is. Weather, hurricanes, storms, the oceans are part of the water cycle. The ice caps are part of the water cycle. This theory I call the flea wagging the dog theory. This says that a trace gas in our atmosphere is now controlling and forcing the water cycle. Very, very unlikely. Talking about signatures, the IPCC, Intergovernmental Panel on Climate Change, talked about a signature in their 4th assessment report. And all of the climate models predict a hot spot in the atmosphere. So picture this as the atmosphere over the surface of the Earth. This line here represents the surface of the Earth. 90N is the North Pole, EQ is the equator, 90S is the South Pole. If you go up 10 kilometers over the equator, over the tropics, all of the climate models predict a temperature hotspot that would be warming faster than the rest of the atmosphere and the surface of the Earth. And this would have to show up if we're seeing catastrophic global warming. But what do weather balloons and satellites actually see? This is what they see. No hotspot found. This is what the models predict. This is what the data from 7 different data sets, weather balloons and satellites, show. Now, the proponents of man-made warming say, well, the models must be right and the data must be wrong. But this is powerful evidence that we're not seeing catastrophic climate change from greenhouse gas heating. As a matter of fact, global temperatures have been flat for the last 16 years, or 10 years if you want. Here's that El Nino in 1998, but they've been flat since 2002 as well. These are data sets from satellites, these blue and red lines. These are the projections of 44 of the world's top climate models, basically all the top models. They all predicted a much faster rise. Here is that temperature rise they're predicting, and it's getting farther and farther away from reality. So the data shows that the models are wrong, we're not seeing catastrophic warming, and there's some real problems with the theory of man-made warming. So what caused the late 20th century warming? Well, if we look at the rise of carbon dioxide, and we look at the temperature graph, if we look closely, we see that carbon dioxide and temperature really don't track very well. Here's that rise from about 1975 to 2000 that everybody's so concerned about. But then we've had flat temperatures and maybe even a little cooling temperatures since about 2000. And we also had flat temperatures, cooling temperatures from about 1940 to 1975. Temperatures were cooling even while carbon dioxide was going up. As a matter of fact, this created the scare in the 1970s. If some of you are as old as I am, you might remember. A lot of people were predicting we had an ice age coming because temperatures were cooling. So a big part of the reason is that big natural feature off the west coast of California. This is the biggest feature on the surface of the Earth, the Pacific Ocean. Covers 46% of the surface of the Earth. You could fit all the land in the Pacific Ocean and still have a bunch left over. Well, the Pacific Ocean has natural temperature cycles that occur all the time, and they've been occurring for thousands of years. Scientists call that the Pacific Decadal Oscillation. It was first named in the 1990s because they're talking about what was going on with the salmon runs. But if you look at the PDO, by the way, the temperature range is about 1 to 2 degrees Celsius that you see. We see that there's warming to about 1940, there's a cooling to about 1975, a warming again to 2000, and about 2005 or so the PDO entered a cool phase and we're starting to see some cooling. So now, if we take a look at temperatures of the 20th century, we can explain those naturally as a combination of 2 factors. If you remember before, I talked about that curve as we came out of the medieval warm period. We've had warming for about 400 years. That's, out of the Little Ice Age, excuse me. We've had warming for about 400 years. That's a long-term rise from the Little Ice Age. And superimposed on that are short-term variations from the cycles of Earth. El Nino, the Atlantic multi-decadal oscillation, the Pacific decadal oscillation. Dr. Ichiaka Sofu says it's quite obvious that the temperature change during the last 100 years or so includes significant natural changes. It's very puzzling that the IPCC reports state that it's mostly due to the greenhouse effect. So we can fully explain the 20th century rise in temperature, that 1 degree that everybody's so concerned about, as a combination of a long-term warming and natural variation. But what about sea level rise? Former Vice President Al Gore and Dr. James Hansen warned of a 20-foot ocean rise by the year 2100. And that would be due to warming temperatures, melting ice caps, and rising oceans. And if the world measures global sea level rise in terms of meters in the next 90 years, that would be a disaster. This simulation shows what would happen to Florida in terms of flooding. To do that, we need to look at the 3 of Earth's ice caps and see what's going on. It is true that Arctic ice recently reached a 30-year low, data from satellites, 2008, 2013. And climate scientists were saying, well, this is the canary in the coal mine. This means that a trace gas in our atmosphere is causing catastrophic climate change. 3 things you need to know about Arctic ice. First, Arctic ice comes and goes. There's many historical accounts of it being low in the past, and we'll see more in the future. Second, Arctic ice is floating on the Arctic Ocean. And if it completely melts, it won't raise ocean levels at all. You can do an experiment at home, put ice and water in a glass, measure it before and after it melts, you'll see there's no change. But most importantly, Arctic ice is only 1 to 2% of Earth's ice. 1 to 2%. Now it's interesting that not 2 weeks after we got to a 30-year low in Arctic ice, we got to a 30-year high in Antarctic ice. 2 weeks later. Antarctic sea ice has been expanding for the last 30 years. And by the way, Antarctic ice is 90% of Earth's ice. They're really concerned about that 1 to 2%, but they seem to ignore the 90%. And by the way, the climate models can't explain why this ice is increasing. And it's interesting to look at the Amundsen-Scott South Pole Station. When I go and present to groups, I always say, we've had a continuous presence there since 1950. This is the 3rd station we've had at the South Pole. Does anyone know what happened to the first 2 stations? And the answer is they were buried by snow. You could still see a little bit of that 2nd station right here. The snow is all up and around it. They can't get to it anymore. Now, Antarctica is a desert, but every year it gets about 8 net inches of snow. And it never melts. You get 8 inches, you get 8 inches, you get 8 inches, you get 8 inches. It gets to be a problem. So what they've done with this station, the new one, is it's modular. There are 7 modules here, and you can see it's built on stilts. So what they can do is they can jack up the station, and that's what they do as the snow accumulates, prolonging the life of the station. Folks, this is 90% of Earth's ice, and it's getting thicker. And then we can look at Greenland. Greenland's always a favor of PBS. You see those crevasses with the water pouring down, like it's some sort of a natural event. But ice has been melting and freezing in Greenland for thousands of years. I need to tell you the story about the P-38 Glacier Girl, though. 8 planes took off from the United States in 1982 to go to England to participate in the war by way of Newfoundland, Greenland, Iceland, Scotland, England. On the way, when they're going past Greenland, they got caught in a storm. They were forced to come back and crash land on the surface of Greenland. All of the pilots and crews were rescued by the Coast Guard, but they abandoned the planes. Then 40-some years later, expeditions went back to try and find the planes. And it took several expeditions, the last one with sophisticated subsurface radar, and then they found the Glacier Girl, and they had to dig down to it because it was buried under 268 feet of ice. You can read about this online, just punch in Glacier Girl. In 50 years, from 1942 to 1992, 268 feet of ice had accumulated on top of this plain on the supposed melting ice cap of Greenland. In fact, the ice cap of Greenland is getting thicker in the center, it's melting near the edges, but overall it's stable. So what does this mean for sea level rise? Kent Taylor talked about 1.8 millimeters per year. Folks, that's very small. That's about a dime. I'm about to write an article in the Washington Times about how tough that is to measure a dime thickness every year when tides vary 10 to 30 feet. But we've only had a sea level rise of about 7 or 8 inches per century, about 1.8 millimeters, over the last 150 years. Mr. Gore and others have predicted 20 feet per year. It's not likely we'll see that. Oh, and by the way, you should also know that oceans have risen about 290 feet since the last ice age. That's all due to natural occurrence. No scientist could tell you how much of this is natural and how much is man-made. Aren't natural disasters evidence of man-made climate change? I want to tell you about the Great California Flood of 1861-1862. Very interesting. Storms came in off the Pacific Ocean for about 8 weeks, December through January, bombarding California, pouring rain on the state. This is a picture of K Street in Sacramento. Water here got up to 10 foot. The governor had to take a rowboat from his house to the Capitol building to be sworn in, and then he promptly moved the government to San Francisco till the floodwaters went down. There was flooding throughout Los Angeles and Anaheim, but the worst was in the Central Valley. And William Brewer toured this area in January of 1862, and he said thousands of farms are entirely underwater. In the Sacramento Valley, for some distance, the tops of the poles are underwater. He meant the 20-foot high telegraph poles. The entire valley was a lake extending from the mountains on one side to the Coast Range hills on the other. Nearly every house and farm over this immense region is gone. Now, at that time, California had about 800,000 cattle, and 200,000 of them drowned in this flood. So imagine the entire Central Valley filled with water, with tens of thousands of cattle, dead cattle, floating in this, and you get an idea what nature can do. You've also heard that Hurricane Sandy is an example of climate change. Very special storm. Normally hurricanes go out here into the North Atlantic. Sandy was heading out. It hit an Arctic high here. It was redirected in, made a direct hit on New York City. At the same time, it ran into a front coming from the west, and it also hit at high tide. And so we had a disaster. But this has happened before. September 1821, the Norfolk and Long Island hurricane came in and hit New York City. By the way, we've had 80 tropical or subtropical storms that have hit New York in the last 300 years. This hurricane was a Category 3 or 4 when it hit New Jersey, much stronger than Category 1 Sandy. And even though we were at low tide, which is about 5 foot lower than what we saw with Hurricane Sandy, it flooded 1/3 of Manhattan Island. Yet people are now saying that this is evidence that a trace gas in our atmosphere is changing our weather. If we look back over the 20th century, 170 hurricanes made United States landfall. 59 of those were Category 3+ hurricanes, much stronger than Hurricane Sandy, Category 1. If we look at global tropical storms, scientists can now look down and look at every tropical storm or hurricane and track it with satellites every hour in its existence. And if you look over the last 40 years, the number of tropical storms, about flat. Number of the stronger hurricanes, about flat. If you look at intensity, scientists can also measure the wind speed of every storm. And they put together a metric called accumulated cyclone energy. And that has gone up and down. Back in 2005, when Hurricane Katrina hit New Orleans and we had 3 other Category 3s make landfall in the United States, we had a big uptick. But recently, scientists were able to say that we were at a 40-year low in cyclone energy. By the way, we're now at 2,800 days since a Category 3 hurricane has made landfall in the United States. That's almost 8 years. We do not have anything that long on record. Typically, a Category 3 hits the United States every other year. We've been 8 years now without one. If we look at tornado intensity, the U.S. count of strong to violent tornadoes, a little downward trend, if anything. 1960s and 1970s had more tornadoes. Last year we had the Great Plains drought of 2012. 80% of U.S. agriculture in drought. 2,000 counties declared disaster areas. Soybean and corn crops down. Many said this is due to a trace gas in our atmosphere. But if you look at the actual data over the last century, 2 graphs here. This is the moderate to extreme drought percentage of the U.S. 1930s, 1950s, drought periods, moderate to extreme wet. We see really no trends of increasing drought or increasing flood in the United States. Carbon dioxide is a pollutant. Kent used that phrase over and over again. News media says that. Environmental Protection Agency says that. As a matter of fact, December 7, 2009 is a date that will live in infamy, not in memory of Pearl Harbor, but on that date, the EPA declared carbon dioxide a pollutant under the Clean Air Act. Ladies and gentlemen, that is bizarre. Carbon dioxide is not a pollutant. It's an odorless, harmless, invisible gas, does not cause smoke, it does not cause smog. What you see here is not carbon dioxide. Carbon dioxide is invisible. This is condensing water vapor. And a lot of the pictures Mr. Taylor showed were photographed at dusk so that these clouds would look black with the sun behind them. We inhale just a trace of carbon dioxide from the atmosphere, but we breathe out 100 times with every breath from carbon dioxide we've produced in our bodies. As a matter of fact, CO2 is plant food, essential for life on Earth. It is a fact that hundreds of peer-reviewed studies show that higher levels of carbon dioxide cause increased plant growth. Wheat, oranges, orange trees, young pine trees, even poison ivy grows bigger and faster with higher levels of atmospheric carbon dioxide. Plants get bigger root systems. They're more resistant to drought. They get bigger fruits. They get bigger vegetables. They get thicker tree trunks with higher levels of atmospheric carbon dioxide. If there's one compound we could put into the atmosphere that would be great for the biosphere, carbon dioxide is that compound. So in summary, when you look out the window, you see the real factors of climate change. You see the sun that supplies 99% of all the energy on Earth. You see the clouds and the rains that have a powerful effect on Earth's climate, and the water vapor, Earth's biggest greenhouse gas, in those clouds. If you live by the ocean, you see the effects of the ocean cycles, like the Pacific Decadal Oscillation. These are the things that dominates Earth's climate. That's what history shows. And that tiny addition of man's greenhouse gases to a trace gas in the atmosphere is very, very small.
Thank you, Steve. And thank you, Kent. We're now going to have a response by each. First, we're going to ask Kent to take 10 minutes and respond to what Steve has presented, and then vice versa. Steve will respond to Kent's.
Good job, Steve.
And finally, we'll have Kent give a little wrap-up to try to bring it back in balance from his view. Remember to write down your questions. Okay, we'll collect those in a few minutes.
Before I start, a couple of quick things. The 1% figure on how much humans are contributing to CO2 emissions has been cited by Harris and Schmidt, and I haven't found another scientist to agree. Generally, even the Heritage Foundation says it's 3.4% to 4%. So I disagree with the fact that we're only 1%. I think you're off by a factor of 3. But let's talk about that ice decline that he was mentioning. Well, it seems that we do have a lot of recoveries, and then we have a lot of declines. Every time it goes up a little bit, there's more recovery. But we have to remember, it's not about sea ice. The sea is called sea ice if it has 15% ice in it. It doesn't have to be deep. This is the trend that we're most concerned with. We have to realize it's the volume, not the area, that matters. And the volume of ice has diminished in the Arctic greatly, which is affecting climate all over the world, including here in the Midwest. And that 1,500-year rotation about Greenland, notice all his evidence. He talks about Rome and England and Greenland. It's all Europe. What's going on in Australia and Africa and Asia? When about every 1,500 years, Greenland temperature declines. And what happens correspondingly? Antarctica's temperature increases. This is a natural bipolar seesaw. These are regional events. Now we're able to measure globally. We just can't look at European records because Europe is affected by many things, including the Gulf Stream. You said the temperature is leveled out. Well, what about 2005? Hottest year on record according to NASA, and 2010 tied it. So we disagree on that. But let's look at statistically. NASA put together a global measure of temperature variation since the 1950s. And back then, and this 3-decade period, we had a natural bell curve, as we've had historically since then, or before then. Just about the same amount of cooler than average days and warmer than average. The next decade, there's a shift. We had to add an extra category, extremely hot. Didn't have to add a category, extremely cold. Next decade, even more. Another shift, hardly any extremely cold. Here we are now, 3 to 4 standard deviations above the norm. These are worldwide data, not regional data. And now extreme weather events that used to cover 0.1% of the Earth now cover 10%. We need to think globally. Water vapor. Yes, water vapor is the most prevalent greenhouse gas by far, and it's very efficient. Here's the ratio. Water vapor is responsible for 50% of the radiative forcing of the greenhouse effect. And on a cloudless day, even more. But look at carbon dioxide is always number 2. And we're not talking about much of a degree temperature, just a small increase in temperatures. Water vapor is a feedback on climate rather than a forcing. It reflects the heat in our atmosphere because the only time that water vapor increases is when temperature increases. And water vapor comes in and out of our atmosphere in a cycle of days, whereas carbon can stay in our atmosphere for decades, if not hundreds of years. So it is not regarded as a permanent fixture in our climate debate. It's basically a wash. When the first reports came out, the skeptics said, well, why didn't you include water vapor? You eliminated water vapor. So, several years later, they started including it. Now they're saying, oh, you're giving it too much impact. So we're damned if we do and damned if we don't. But water vapor essentially is a wash on our climate change. Because warmer air holds more water vapor. Each additional 1 degree centigrade, our temperature, increases our capacity to hold water by 7%. There's already 4% more water vapor over our oceans than there only was 30 years ago. So if water vapor's the most prominent forcing mechanism, we're actually creating more of it as we go on. But I really wanted to get on to a couple of things in my rebuttal. Truth has been attacked since the time of Galileo, and Copernicus, and Darwin. When something comes up that challenges the status quo, there's always somebody to attack it, usually institutions. They say there's no scientific consensus from the first attacks. However, we know that not to be the case. Scientific consensus is as strong as any in any theory. Of all these peer-reviewed studies from this period of time, 20 years, 0.2% disagreed with what I'm saying in this field. It's a very lonely crowd. Every National Academy of Science on this planet agrees with what I said today. Every single one. Here's what they had to say. It's pretty blunt, pretty direct. How many National Academies of Science disagree with what I say? None. Every major scientific society in the world in fields related to the study of climate and atmosphere agree with what I said today. These organizations have my back. You need to ask, who has the backs of the denier community? Well, I think it's a pretty obvious question because we know the answer to that. Fellows by the name like Rex Tillerson, head of Exxon. After he made this incredibly stupid quote, I had to look for more quotes that he's done for my cause. And here's the money quote. Here's the one where he looks at you guys and essentially insults you, saying it's an illiterate public, we have to educate them and help them realize that we'll easily adapt to this. Well, it's easy to say for a multimillionaire. But we've seen this sort of strategy before, putting out these red herrings to distract us from the overwhelming scientific consensus. A lavishly sponsored campaign started 20 years ago to distract us from the problem. And a memo that was leaked to the press several years ago revealed their strategy in their own words, which is to reposition global warming as a theory rather than a fact. Well, we've seen this before? Yes. From many of the same people. That's right. They'd recruit doctors and try to convince us that cigarette smoking was good after the Surgeon General said it wasn't. They spent millions on product placements influencing the media.
Cigarette, doctor? Thanks, doctor.
But the truth bore out. Now instead of product placements, they're placing politicians and experts, because there's no movies that are going to show climate change. Coal, clean coal, has been argued and presented by the industry forever, since the 20s, into the 40s. They're always promising clean coal. It's just around the corner. We can burn this stuff. It's not going to do any harm to us. Do not worry. It's cool. It's green. I don't know, does that remind me of something? Yeah. Reminds me a little of that character, Joe. No, it's not the time for clean coal. Now it's time to take action. We need to listen to the smart people, the people who have been proven right time and time again to how we have to face problems. We are now, civilization has thrived in a very narrow temperature range. And we can see the Vikings in Greenland in the medieval warming period, but they've always been in a range. But now we're about to pass out of it for the first time in human society. And that's what scares me, because we do not know how that's going to affect us. We've had multiple mass extinctions in the last 600 million years. Well, we're in one right now. Welcome to the Holocene. Or, as any geologist 10 million years from now that might exist, they'll be calling it the Anthropocene extinction. That's our extinction. Our fault, and maybe our species. This is important stuff, because there may be an Earth where this reality doesn't matter. But it isn't this one. This one is the only Earth you'll ever have, or love, or touch, or tend for our children and their children. This is a very serious topic, folks. And that simple truth is our reality. Thank you.
Well, Ken, I'd really like to use one of the charts you just put up.
Which one?
But I'm going to avoid that one.
You want this, Steve?
Unless you want to go back.
Want that or not? Here, I'll leave it right there.
This one, I think this is an interesting chart, and the interesting part about this chart is, here's the temperature trend, and here we are today. Everything you see here is a computer model projection. There is no evidence that we're in a dangerous period of climate change. As a matter of fact, where are we here? If we go back to what the IPCC said in 1990, under the business as usual emissions of greenhouse gases, a rate of increase in global mean temperature during the next century of about 0.3 degrees Celsius per decade, with a range of 0.2 degrees Celsius to 0.5 degrees Celsius per decade. So I've plotted those. We've had 23 years now to take a look at this. Here's the 0.5, here's their best estimate 0.3, here's their low estimate. They said this is the lowest that we're going to see in global temperature rises, but we sit here today far below the low estimate. The empirical evidence shows that the climate models are wrong. We are not seeing catastrophic global warming. I want to go back and talk about carbon dioxide a little bit, because Mr. Taylor kind of hinted around that when we get temperature rise, we get carbon dioxide rise. All that is true. But when they took a look at these rises more closely with higher resolution, they found that the carbon dioxide concentrations increased 600 years after warming on average. In other words, temperature rose first, carbon dioxide rose later. This happened in every case for the last 4 ice ages. Carbon dioxide does not force temperature, it's a result of temperature. Temperature goes up, the oceans warm, they emit carbon dioxide goes up in the atmosphere. Sorry about skipping around here. We also heard today that 97% of the scientists accept man-made warming. I want to show you where that comes from, because that's been in the press. The president has even said it. Many people have said that. That came from a survey done by Doran and Zimmerman in 2009. They sent out 10,000 to 10,000 members of the American Geophysical Union online, and they asked 2 questions. When compared with pre-1800 levels, do you think that mean global temperatures have generally risen, fallen, or remained relatively constant? Well, pretty much everybody would answer they've risen. We've come out of a little ice age. Second question, do you think human activity is a significant contributing factor in changing mean global temperatures? They didn't say is it catastrophic. They didn't say is it the dominant factor. None of that, just is it significant, which was a little bit fuzzy. They got back about 3,000 responses, and out of that they made a judgment of which of these 3,000 were climate scientists. That totaled out to be 77, and 75 of those 77 said yes, we think it's rising, and yes, it's significant. So this 97% is an opinion of 75 people, folks. That's where this comes from. I hold in my hand a copy of the Global Warming Petition Project, signed in 2007. It's a thick book. It's got a little climate science in the front, but it also has a name of 31,000 names of 31,000 United States scientists in here. They're not all climate scientists, but there are 9,000 PhDs renowned in their field. And I'll read you the last part of their statement. There is no convincing scientific evidence that human release of carbon dioxide, methane, or other greenhouse gases is causing or will, in the foreseeable future, cause catastrophic heating of the Earth's atmosphere and disruption of the Earth's climate. Moreover, there is substantial scientific evidence that increases in atmospheric carbon dioxide produce many beneficial effects upon the natural plant and animal environments of the Earth. So I ask her, are all these people in the pay of the energy companies? Or the smoking companies? Not true, folks, not true. Don't let anyone tell you that we have a consensus or that all of or 97% of the scientists believe. Let's see what else I've got here I'd like to go over. Let's talk a little bit about ocean acidification. This is a misconception. First off, the oceans are alkaline. They will never be acidic. The midpoint of the pH scale is about 7. The oceans are approximately 8.2. I agree with Mr. Taylor. There are pollutants we're putting into the oceans. There are humans that are causing damage to coral reefs. We do have some problems with coral reefs. But the idea that it's caused by carbon dioxide, there is no evidence for that. The climate models predict a reduction in pH to about 7.9, about 0.3 of a pH in the next 100 years. But studies show that natural variations are huge. A study by Hoffman done in 2011 took 15 locations across the globe, kelp beds, coral reefs, open oceans, and they found variations in pH as much as 0.35 units per day at these locations. That's as much as the models say are going to be a catastrophe in 100 years. Neither are we seeing a problem with coral growth. If we look at the amount of calcification that occurs in coral, they can look at coral and see what its past growth record is. This is for coral growth at the Great Barrier Reef. You see that calcification rates, except for this little piece here, have been increasing for the last 400 years, even though we've had rising global temperatures. And finally, this is from a diver friend of mine in Australia, a guy named Halstead. These are photographs from the Coral Sea. And interesting, these bubbles are natural carbon dioxide vents. It just bubbles right out of the ground under the ocean. Here it bubbles out of the seagrass. There are more than 1 million vents in the bottom of the ocean that are bubbling carbon dioxide out. Now, Bob Halstead tells me that a diver can't hold his hand over one of these vents. It's too hot. But nevertheless, with the carbon dioxide and the heat, boy, the seagrass is doing great and the coral's doing great. There is no evidence. There is evidence that the coral is impacted, but the idea that CO2 dissolving in the oceans is causing it, that is only a computer model projection. How much time do I have left?
1 minute.
1 minute. Okay, I'm going to do a final summary here. There are many real problems in the world that need solutions. This is a picture of Africa at night. There's 1 billion people on the continent of Africa, and as you can see, there aren't many lights on. They don't have much electricity. Compare that with Europe here and India here. Every day, 20,000 people die from hunger-related causes. 2 billion people on this planet are trying to live on under $2 a day. 1.8 billion don't have proper sanitation. Almost 1 billion don't have proper drinking water. 1.4 billion don't have electricity. Millions die every year from diseases, AIDS, tuberculosis, malaria, diarrheal diseases. Yet the world is spending over $250 billion a year to try and stop the planet from warming up. The world's on track to spend $1 trillion in the next 4 years. Wouldn't it be something if we could take that $1 trillion, put it towards sanitation, health, education, all the other things, and solve the real problems of the world instead of a futile attempt to stop the planet from warming up? All right.
Thank you, Steve.
Couple of things, some low-hanging fruit here. I never said all scientists. I said climatologists. If you want to see, if you have a pain in your chest, you go see a bone doctor. They're both doctors, but who are you going to believe? The cardiologist or the orthopedic specialist? My work is with climatologists, not just scientists. Many scientists don't know a hill of beans about the atmosphere. And I never said that acidification was hurting the coral. I said the temperature was hurting the coral. Acidification could hurt it in the future, but right now, the temperature is going to kill it before the acidification. You're in my wheelhouse now. Also, Al Gore had never said, to my knowledge, we'd have 20 feet of accelerated ocean rises. I don't recall it, but I'd certainly like to see that attribution. I'm very curious about that. Yeah, but he didn't say by 2100, 20 feet. He said if those 2 ice domes, half of them melted, then. It was an if-then equation. We know it's a fact. That it's happening, and it is real. We're now conducting a massive chemistry experiment on our atmosphere. It's a game we're hoping to win by rolling 1 or 2 degrees of temperature instead of 7, 8s, or 9s. We're taking a risk because it's convenient to take that risk. But the odds are getting stacked against us. We're loading the dice. So it isn't even a fair game anymore. What's more, it's like we're painting more dots on these dice. So we're actually capable of rolling 13s in 14s. It is not a game we can play. This is not a game. So you feel unlucky? Corporations and people use risk analysis to make their decisions, unconsciously and consciously. Let's do one for the climate crisis we're in right now. What's the worst that can happen? That's what we always try to analyze here with a risk analysis. What's the worst thing, and then we try to avoid it. So we have an axis here of anthropogenic global warming. It's happening, or it's not. Actions. We take the actions I would recommend, or we do nothing. Let's fill in these boxes. All right, let's say I am wrong. And we take all the actions, and we've cost all this money, this $1 trillion you're talking about. We may get a global economic depression. That's pretty bad. We've just been through one. That's a bad outcome. If it's not happening, and we take no actions, we made the right decision. We're all happy. Let's keep going. Let's say we take these actions, and I'm right. Well, we still have those costs. Hey, but we saved the world. We saved civilization as we know it. Not a bad outcome. Now let's say I am right, and we take no actions to mitigate the problem. Scientists tell us we'll have catastrophes all over this planet, from rising oceans, rising temperatures, increasing volatility of storms that cause geopolitical, economic, public health, environmental, you name it. All aspects of our society are affected. So which is the risk that we want to take? Well, actually, this one isn't so bad because you know what? Even with those costs, we're going to get something for it. We're going to have an energy infrastructure, a better economy, less oil dependence, cleaner environment. So now, we have to start thinking about which actions to take. Think about the columns, not the rows. We have to stop this debate and start beginning to contemplate which actions are smart and which aren't. There's too much at stake. We can't stick our head in the sand any longer. So, are you feeling lucky? Really lucky. Think about it. And thank you.
Well, thank you, Kent and Steve. Let's have some questions. Heather, will you pick up some of the questions here? What models of weather do men and women use to predict the weather? Are they computer models? Are they other graffical models? Do you know how
They're not fashion
I
models.
can try it. You may know more than I do. But
Can I lead off?
Go ahead.
These are computer models that have only really become possible since the invention of the supercomputer, which is only maybe 30 years old. And they're like models that your financial planner will use to predict where your investments are going to go in the future. What they do is they figure out a bunch of variables, and then they back test it to see if this model works. Let's back test it over time and see if it would have predicted all the temperatures and changes in climate up till now. And by that test, they can then project in the future, but only after it's been back tested. Steve?
I think the question was about weather prediction, and actually,
Weather models.
yeah, the weather models have gotten to be pretty good. They're feeding in a lot of data. They've got radar. They could predict maybe a week out pretty well, maybe 2 weeks out. The problem is this predicting 50 or 100 years out. That's where we have some real problems, because the Earth is a chaotic system, and we have things changing all the time. And I would differ with Mr. Taylor. I don't believe the climate models have been adequately validated, and the recent flat global temperature shows that the predictive power is very limited.
Sort of a related question is there a new IPCC report coming out, and do you have any indications, either of you, of what that report might suggest?
Yes, you want to go first?
Yeah, it's coming out this month, and it will say now that there is 95% probability of anthropogenic climate change affecting our society and civilization adversely. Right now, they're arguing over the effects of ice melting. And IPCC has to, when they announce a report, all the nations have to agree. So it's a compromise. And every report they have issued, things have turned out worse. In terms of ice loss, in terms of acidification of the oceans. Steve's right. Temperature has not gone up as much as some models, and good models, had predicted, but I explained that because the ocean has been absorbing much more than they thought possible. And again, that ocean has been our shock absorber.
Well, I would, the IPCC is putting out their fifth assessment report. I would disagree. Pardon? Not loud enough. The IPCC is putting out the fifth assessment report. I would disagree that it's a balanced document. There have been a number of hiccups in the past. I've shown a few of those. They also published the Michael Mann temperature proxy that went back 1,500 years in the 2001 third assessment report. They dropped that proxy in 2007 because it turned out, but they had taken this thing, it showed no medieval warm period, no little ice age, and a big rise in temperature. They broadcast that to the world. That study was mailed to everybody in Canada, everybody in the UK. And then scientists got the data and started feeding in data into the algorithm, and they fed raw noise, white noise into this algorithm, and they found it always produced a hockey stick. It didn't matter what data you put into it, and the IPCC dropped that in their fourth assessment report without an explanation at all. So they've had some hiccups.
How old is the IPC?
It started in
1989.
1989, first report in 1992. They met in Rio de Janeiro.
1988, yeah.
And the satellites that NASA put up that are monitoring weather and temperature and things, those are, I heard that they're nearing the end of their useful life. Do you know anything about the satellites?
Well,
and what
they first went up about 1978, I believe. So we really only got about 30-some years of satellite data. But they continue to put up new satellites to replace the old ones.
Well, no, I disagree. With the
Okay,
budget's
fire away.
being cut so much.
Okay.
And unfortunately, remember there's a missile that blew up, one of the few satellite launches that blown up in American history? It happened to be the satellite that Al Gore was responsible for pushing before 2000. It finally got launched. Unfortunately, it blew up. It was to monitor our climate in the future.
There have been some cuts, but climate science has not been starved for money. It's increased about 1,000% in the last 20 years. So,
Well, here's a question that's really global. What do you know of that's being done to involve other nations of the world who may yet still be developing in their energy use and agriculture and so on? China, India, Russia.
Can I take this first, Steve? It's an intractable problem, because here's the bargain. We put all this fossil effluent up into the atmosphere as we developed our societies. And now we say, oh, there's too much up there, we can't do this anymore. Then the people in the poor areas of the world that haven't developed say, well, what about us? And they say, well, we say, it's just too late. Sorry. We did the damage, now you're going to figure out some other way. So that's why there is a logical argument where the developed nations have to assist the underdeveloped nations not only adapt to climate change, since so many of them are poor and in their coastal areas, but also afford to make the changes in their energy structure. So they don't take the same path of fossil fuels that we did. It's an unfair advantage we have, and I certainly understand the logic of that argument, even though it does pain us a little bit to realize where we may have to be sending funds to other countries to help them mitigate what essentially the developed world has created.
well, all this question is based on the assumption that we're causing dangerous global warming, of course, which I would dispute. However, we do have a situation now where China is now putting out about double the emissions of the United States. Matter of fact, if you think carbon emissions are a big deal, the U.S. has been the fastest nation cutting carbon dioxide emissions, faster than Europe over the last 15, 20 years, and that basically is because of the hydrofracturing revolution. We're using natural gas instead of coal for most of our power plants, largely because of cost. But it is a significant issue, and if you heard President Obama's address in June or early July, he said he was going to try and stop providing loans, providing assistance to developing nations for building coal-fired power plants. And I think that's the wrong policy. That's going to create real income issues, lifespan issues, poverty issues, and everything else. So we better darn well be right about this carbon dioxide thing.
I'm an engineer, and working in the building industry, construction industry. I know it takes a very long time to go through the peer review process to develop new codes for life safety and so on. What is the process that's being used to refine the models, to refine the data, to improve the data?
It is an exhaustive process. And essentially, the data is always being refined. The object of a scientist loves to find somebody else's mistake because they make a name for themselves. So they will review articles that are published in substantial magazines such as Nature. And then they'll publish articles that can refute that, or maybe they cite it and take it to another level. But there is no scientific conspiracy here on global warming, because think about it. If there was one climate scientist who had the pencil and paper, the agreement that we would be fudging the data, he could sell that to oil companies for millions of dollars and be the most famous scientist in history.
Well, I would agree with Kent on that. I don't think there's a conspiracy as well. The problem I see is two factors. One, the world jumped to a conclusion on this. Climate has always been very uncertain. In 1988, Dr. James Hansen came before Congress, said he was 99% sure the Earth was warming and mankind was causing it. Just 1 year later, the IPCC found man was causing dangerous climate change. And 3 years later, at the Rio de Janeiro Earth Summit, 41 nations signed a treaty saying that they would reduce greenhouse gas emissions. For the last 20 years, our leaders have been arguing about how much to reduce emissions and when, and yet we see more and more data that shows, yeah, the climate models may be off. That's factor one. And factor two is the momentum and the money behind this. We have hundreds of $millions in carbon trading in Europe going on. We have environmental editors at newspapers. We have deans of sustainability at universities, corporate vice presidents of sustainability. The United States government puts $9 billion into climate change research every year. And that money goes to NASA, NOAA, National Academy of Sciences, EPA, and then it goes out to every university. And there's one thing you shouldn't say if you want funding to study climate change. I think it's natural and not man-made. Then you don't get the funding. So we have a lot of momentum behind this. It's going to take many, many years to turn it around.
Can I make one comment?
Yes, sir.
Very
Let's
briefly
make the
on
last comment, and then I want to thank everyone.
We'll do it informally afterwards, folks. Yes, they jump to some conclusions, because if we wait until everything is manifest, till it's absolutely certain to everybody, it's too late.
Let's really thank both Kent and Steve for an excellent job.
Thank you.
Second, I want to thank all of you. We have an overflow crowd. We had to get more chairs. I think that just says a lot about our community. When I came here from Detroit, one thing that impressed me as I read the history of the North Shore was the incredible debates that took place over the last century here. And I think we're continuing that. I've learned a lot myself on both areas of this question, and I hope you have. What we would like to do is give all of you a chance to individually chat and talk. We wish we could take another hour, but we just don't have that luxury with the library. And we also have some materials you might like to talk with the gentleman about. So I want to thank you all for coming, thank you for your questions. We're going to get these questions back to both Kent and to Steve as well, even though they won't be able to answer it from the stage tonight.
The other
And
thing
so
is,
they'll
you
have
can
them.
pick up a business card and send us an email. We'll try and answer them that way.
Yeah, they're very
both will do
personable,
that.
and they, as you can tell, they love talking about this subject. They're well informed. They have studied it, so they are experts to talk to
Well,
in their area.
I'm a researcher.
Now Steve's
I don't
going to go to the
claim
back of the
expertise.
room where he's got some books to sell, and all I have is a bunch of business cards. But and I'm sure he'll answer some questions back there as he autographs your books. I can answer some questions up here from people if they'd like. It's just we won't be broadcasting it or probably filming it.
Thank you both very much.